talked about solving equations that look like this. 3x plus 5 equals negative 2x plus 1. We talked about solving them by a table or a graph. Okay. Both of these, the graph is actually the easiest if you have access to like Desmos. Okay. The table is only not good unless you know where to kind of start and all that. The table is actually hard. It's good to use though if you're given an equation to begin with that works, and then you I mean if they give you a table to start with, you can look at the table to kind of guess some answers. But this one is so far the best. Okay. And that's graphing on Desmos and being able to look up that line. But for practicality purposes, that's not what we do. Okay, so what we do is we're going to learn how to solve this algebraically. This is what we're actually working on, is doing stuff algebraically. And that's using the numbers and symbols to find out what the answer equals. Okay, so we're going to solve this. 4 is solving ax plus b equals cx plus d. So this means these numbers are not the same. A, b, and c are all numbers. Okay, it's an equal sign. Okay, we are going to get, most of the time, 99% of the time, you would get an x equals to a number as the answer. And what that is that x, if put into equation, would make the equation true. So you can actually check these because you can put the value back in and you will know that that's true. Okay. 4, 5 is not much difference. 4, 5, but is a little different in a few places. It's solving ax plus b is less than cx plus d. And it doesn't matter which combination you put there, so it's one that is greater or less than or equal to the other.
Wait, are you doing 4.5 now? Or are you doing like...
I'm doing them together because they're very similar. Okay. So in 4.5, instead of solving an equation, we're solving an inequality. Okay. But when it's an inequality, we're going to get a whole range of numbers. We don't just get one answer. Okay. We get a range of answers that make it true. And to check it, we put a number in that range, a number from that range into the inequality. And it will make it true. Okay, so again, same process pretty much, but one you're getting just one number. Okay. Occasionally this comes out to be more than one number or less, no numbers at all. So the 1% of the time we can get no answer or what do I say? All answers. That means all numbers. I should say all numbers. So these two are the special cases. Okay. This, we will always just get a range of numbers. There's no exception to where there's no answers or all answers. Okay. So that's kind of the difference between these two. And then there's one special condition we have to remember when we work with inequalities. So the special condition for this one is, what do I have to remember when I am moving things with inequalities? Yes.
If it's a negative number or what?
If it's negative, when you do what?
Divide on both sides.
Divide or
Multiply.
multiply. Negative number when multiplying or dividing, what does it do? What does the negative number do? Yes.
It switches the greater than less than.
Yeah, switches the sign. That's the only difference between solving an inequality and solving an equation, except for how many answers you might get and that kind of thing, okay? You're definitely never not going to get a whole range of answers in an equation. You may get all numbers that work, or you may get no answer that works, and we'll look at both of those today. And then over here, you're going to get a whole range of numbers that works, okay? Now, if it's equal, it will include the one that's equal to it, okay? So that's the difference, but most of these are just inequalities that we're looking at. So let's just start with some. Let's, in fact, start with this equation right here. 3x plus 5 equals negative 2x plus 1, okay? Remember, our goal in solving is to get our goal. When we are solving, our goal is to get x equal. 1x equals a number. That's our goal. Over here, our goal is to get x less than or x greater than a number. Okay, so in both of these, we're trying to get it down to 1x on one side. Notice that the x's are on one side of the equation. Here I have x's on both sides of the equations. Okay, I have 3x on this side, negative 2x on this side. I need to get all the x's together. So since they are on opposite sides of the equation, how would I do that?
You would add 2x on both sides.
Okay, because this is negative 2, they're on different sides. So to move them to the other side, we really want to eliminate this one here. The way I eliminate this one is to add 2x. Because negative 2x, positive 2x is 0, so we basically ended or eliminated it there. But when we do it on this side, we must also do it on this side. Okay? So what we come up with is 5x plus 5 equals, that equal sign does not move. These actually canceled. I like to do it like that so we don't have the 0 there, but in a sense, that's what they did. Plus 1. So we have a 1. Now, we've done a lot of these problems.
1x, right?
No, because you notice the negative 2x and the positive 2x actually cancel. What do I have left? A positive 1. Okay? So there's not any x's left because we actually got rid of those by canceling them out, adding and subtracting. Okay? So now we've done these. So what would be the next step for this one, Ava?
Adding positive 5 and positive 1.
We want to add them together, but notice they're on different sides of the equation. So what am I going to do? Okay, we would want to move the 5 over to the 1. So that means get rid of it here. Okay, so I'm going to have to subtract 5. You're right, we want to get them together, but we have to realize they're on different sides. So I have to move it from one side to the other. Moving it just really means eliminate it on this side. And then to keep it balanced, we have to do the same thing on the other side. Otherwise, my equation is no longer balanced. So now I get 5x equals -4. This is where you just have to really watch. Make sure you do your addition and subtraction of positive and negative numbers correctly. Okay, so now I have 5 times x equals -4. Max, what are we?
Divide each side by 5.
Yes, we want to get this to 1x. We don't want to cancel 5 out. We want to just make it a 1. So the only way I can make it a 1 is divide by 5, because 5 divided by 5 is 1x. Our goal is to get 1x equals, I have to also divide on this side, so my answer is -4/5.
Or negative 0.8.
Yeah.
Yes, this one you can actually do -0, I can't write. 0.8, because that one actually terminates, it stops. So we don't have to round to get that answer. We really want to leave them in the most exact form. If it stops like that, that's an exact form.
But if it's like,
If it's repeating, you can't use that. You want to leave it in fractional form. Okay?
What if
So-
it's like 0.86753? Like, what if it has 4 numbers after it? Do we just use the?
Does it stop?
Yes.
You have to know if it stops.
say it just stops.
The calculator stops it.
The calculator stops, but you can't believe that. That's what you
Okay.
need to know. I will tell you that it's kind of hard to do. If you prime factorize a denominator, if it's only 2's and 5's, it will stop. That's kind of an interesting statement, but so if you take any number like 160, I don't know if this will work, but you prime factorize it. You guys know what prime factorization is?
I think so.
Okay, well, I'm gonna say, what are 2 numbers that multiply to give me that?
2 and 80.
Okay, 2 and 8, okay? Is 2 prime?
No.
Yes, it is, because
Yes, it is.
nothing else divides into it.
Well,
That's what I said, my tongue slipped.
Okay,
Ah, yeah.
80.
Sure.
Can I think of any numbers that multiply to give me 80? Yes.
40.
40 times
That
what?
would beat you up.
2.
Whoa,
2 times 40. Okay, 40,
a prime.
or 2, I can't
That's
break
a prime
that down,
number.
yes. 40,
20.
and
2.
2 and 20, okay, you guys are going down by 2's all the time, okay. So 2 is prime, is 20 prime?
Ten.
No.
No.
10
Okay.
and
No, 5.
Ten.
We're gonna do
Okay,
5
5
and
and
4. Okay,
Yes.
we're gonna do 5 and 4 this time.
It's still gonna be
Okay.
basically the same.
You suck.
5 is prime, you'll still end up with the same thing.
And
If
then
you do it
2
in
and
2.3.
Then this is
2.3.
2 and 2. Now, if you look at this, 2, 2, 5, 2, 2, 2, the only numbers in this factorization, in the prime factorization, are 2's
And 5.
and 5's. Those will stop. They do terminate.
Wait, so if you did.
Because we're a base 10 system, 2 and 5 are part of the base 10. So these will always stop. If you end up with a 7 in here, a 3 in there or something, it will not stop. Okay, it only has to be prime. That's just an extra thing that I threw in just so you can know if you wanted to know if one actually stops on your calculator. Okay. To check this, we're going to go back to and put it in. So we can do -0.8, plus 5 equals -2 times -0.8 plus 1. 3 times -0.8 is -2.4 plus 5 equals -2 times -0.8 is positive 1.6. If I subtract that, I get 2.6. If I add that, I get 2.6. Notice it checks. So I can know if my answer is correct by going back and checking it. Okay? So in an equation, you always put exactly what you got back in. Okay? And that will give you a true equation. Okay? So that's how you check an equation. It's not true of other ones. So, in this one, if it was an inequality, 3x plus 5 is less than negative 2x plus 1. Same idea. Okay? The only thing we have to ask ourselves is each time we do something, did we multiply or divide by a negative? If we didn't, it's exactly the same. So here, negative 2 is on a different side than 3. So I'm going to add the 2x here, and I'm going to add the 2x here. It eliminates it here. That's what we want to do, is eliminate the x's on that side. We want to get rid of them there, so we move them over here in a sense. That gives me 5x plus 5 is less than 1. Okay? Doesn't change. I want to get these 5 over there, so I'm going to subtract 5. I don't know where that 6 came from. Subtract 5 from both sides. That eliminates that on that side, so we have 5x is less than negative 4. Now, here's my division, but I'm dividing by a positive number. So I am not going to switch the signs. I'm going to keep them the same because I'm dividing by positive 5, so I get x is less than negative 4/5, okay? Now, to check this, what's a number that is less than negative 4/5?
Negative 1.
Negative 1 is less than that. Because remember, when you're looking with negatives, I always like to remind people of this. Negative 1, negative 2, basically the number looks like it's increasing, but it's actually smaller because it's farther to the right-hand side, okay? This is smaller. So if I'm looking at negative 4/5, which is right about here, this is negative 0.8. That's negative 0.8 right there. Negative 1 smaller, negative 2 smaller, negative 3 is smaller. Any of those you could put in there to choose it. You have to just pick one of them that's in this range. Okay? So negative 1's a beautiful one. 3 times negative 1 plus 5 is less than negative 2 times negative 1 plus 1. Negative 3 plus 5 is less than positive 2 plus 1. This gives me 2 is less than 3. Yes, it works. I picked a number within that range, and it works. That's how you check it. Okay. So the way we check an equation is a little bit different than how we check an inequality, because we have to choose a number in that range. And the trickiest one is when you're trying to think of stuff that's smaller. Just draw it on your number line. Smaller always is to the right-hand side. Okay, so if you need to draw it on the number line where it is, and then figure out what numbers are smaller, that's fine. You can do that. Okay, that's not a bad thing. Okay, but again, I think as we said before, you can choose any number. Don't choose a fraction. Choose a whole number. It's much easier. Okay, negative 1 is an integer, so choose an integer if I want to be exact on my words here. Okay. Let me show you one now here that gives you either no answers or all answers. These are my special cases. Okay, so here's what we're going to show you. This only has to do with equations. Okay, so these are my special cases. We're going to start with one that has no answer. They're pretty easy to recognize to begin with. So I'm just going to say if I have 3x plus 4 equal to 3x plus 5. Okay, just look at that equation for a minute. 3 times the number plus 4 is equal to 3 times the same number plus 5. Is that true? Can you do that? No. So we know that's not going to have an answer. But what I want to show you is when you work with this, what happens. Okay, so you can identify it. So if I go to move 3x, I'm gonna move 3x here, I'm gonna move 3x here. Huh, what happens to my x's?
They disappear.
They all disappear, there's no x's left. I get a statement that says 4 is equal to 5, is that true?
No.
Not true, no answer. Means I can't find an x that works. Okay. That's the first special case. When they're not true, there's no answer. Okay, so I'm gonna do a different one this time. I'll just make it nice and easy. I want to make this a little harder, but I think most people can look. Our first job would be to do what?
Get rid of the 3.
Well, how about if I
Oh,
distribute?
distribute.
Distribute would be first on this one, okay? So I would get 3x, 3 times 2 is 6, equals 3x, whoops. Huh, what do you notice about those?
They're the same.
They're the same. That's a true statement, isn't it? 3x plus 6 does equal 3x plus 6.
Yeah.
Now, let's see if we go farther. If I take the 3x away, take the 3x away, they go away just like as up here, but I get 6 equals 6. If I get a true statement, then we can put any number in and it will always work. Any number is the answer. And we can check that. We can just try numbers. 3 times 2. Well, we would do it this way. So it'd be 3 times 2 plus 2 equals 3 times 2 plus 6. 3 times 4 is 12 equals 6 plus 6, which is 12. Notice, I put 2 in and it came out to be the identical. You could choose another number. Let's say we put -3 in. So we're putting 3 times -1 plus 2 equals 3 times -1 plus 6. So this gives me 3 times 1 equals 3 times 3, which is, or 3 times -1, which is -3 plus 6. Add those together, I get 3 here, 3 here. Notice it's true when I put -1. So any number you put in, it will always be true. Okay? So those are the special cases, when there's no answer and when there's all answers. I didn't put that in here. 2 is all answers. And that is starting down here. There we go. That's your no answers. So those are the 2 special cases. So if that happens, you know. If it's not true, I mean, kind of just thinking about this, it's not true. But if you don't see that right away, go down until the end, and if it's not true, then it's no answers. If it is true, then there is all answers. Everything's the same. We're going to talk about what does that actually mean on a graph. We'll talk about that later, what that actually means. Okay? So that is 4-4 and 4-5. That's what you're doing.
Easy.
Yeah, it's not bad. Okay? So